Hmm. Hey, welcome back. Today we are learning networking basics too. Um, Yesterday we stopped at a phase where we are trying to convert the CIDR into an address format. Okay, so we'll just go through it again one more time, and then we'll proceed to the next the topics. So this is the CIDR we took 192.168.0.1/24. Yeah. So if I take this slash 24, right? So what it says is it's a 8-bit, it's a 4-bit one. So that would be like 32 is the one. So 24. Yeah, sorry. So we are supposed to look for 8-bit. So that would be your network address. So that format will go like this. So in the 32-bit IP address, so we are looking for the 8-bit one. So here we are saying 24 is the network address and 30, the rest of the thing is the subnet. Okay. So how do we specify that? Let's take for 28. Okay. So we are looking for here first 28 bits. Uh, 24. 32. My bad. So here we are looking for first, we are taking slash 28 and we are looking for first 28 bits. So that would be here. And so 25, 26, 27, 28. So, so this is what we are mentioning. We are saying like first 28 bits are the subnet here. So what do we do? So what do we do? We will convert this one into a subnet. So we will take the last one. The first one, it says like this, 255. If I calculate everything, it will be 255. So this one is a 255. This one is a 255. And this one, so we will count it separately. So that would go like this. And if we read it like once we learned in the school, right? Like the binary representation. So it will start from the bottom. That would be 2, 4, 8. Sorry, it starts with 1. 1, 2, 4, 8, 16, 32, and 64, and 128. So if we calculate everything, so we will get 128 plus 64 plus 32 plus 16. So that would be somewhere around 240, I guess. Yeah, this is the 240. So this is the subnet will go here. So for this CIDR, we are mentioning /28 CIDR, the subnet will go like this up to 240. And we got to convert this address as well. So for that, this is the EA and this is the B. We need to do AND operation on top of this. So that would go like AND operation says, so if it's 0 plus 1 is equal to 0. And let's say you have 1 plus 0 is equal to 0. And we have 1 plus 1 is equal to 1. So we will recheck everything. So this one would be, yeah. So this one would be, this whole thing will get 0. Okay. And this whole thing also will get 0. And this thing, so we have ones here and ones here. So we will get it something like this. So 1 plus 1 is equal to 1. And 0 plus 1 is equal to 0. 1 plus 1 is equal to 1. 0 plus 1 is equal to 0. 1 plus 1 is equal to 1. So the rest all would be zeros. And this one, it's the same. So 1, 1. So the first two would be, yeah. So this is our address. So what we are supposed to do? So we are supposed to convert into the regular format. That would be like this 0, 0, and this one would be, I think this is the same thing. So 168, and this is the 192. Okay. So our address goes like this. Address says starting IP would be 168.0.0. Okay. And the last IP would be, so here the bit range is 28, right? So how many address we can use that we need to recheck? So this is a 8-bit. So we need to recheck with the 2. So this is 2 to the power of 8. Right. Sorry, this is 28. 4-bit it is. So 2 to the power of 4. So that would go like this. 2 into 2. So 2 fours are 8, 8 twos are 16. So that is 32. So we need to add 32 IP addresses. So that would become dot 31. No, just a second. It's not 32, just 2 fours, 2 twos are 4, 4 twos are 8, 8 twos are 16. So we have total 16 IP addresses. So that will become like this. In this first IP, we will reserve for the network. Okay. This is the network address. And the last one would be broadcast. This is for broadcast. And total, we have usable IPs are 13 usable IPs. Okay. And our subnet would be this 255, 255, 255.240. Okay. So this is how people does calculate the CIDR. I'll take another example just for a clarity. Okay. So let's take something like, so I'm taking this CIDR now. So what we do, first we will convert everything into binary and this one as well. So 168, 120, and 45. Okay. And as I mentioned, this is 25. So we are checking for the bits. So that would be 32 minus 25. That would be 7. This is a 7-bit subnet. So how do we calculate the next one? So we need to shift the digits so that first 25 digits are the subnet IP. So what do we do? So we will take an example from here. Let's do it. Right? 8, 8 is 24 plus 1. So that would be 1, 0, 0, 0. Yeah, so this is it. And how do we calculate our subnet? This would be 255, 255, and 1.0. That would be from here, this table. This is 128, right? So our subnet would be 255.255.128. Okay. And we are supposed to do an end operation here. So between these two. So if we do here, so we get, this is the one. And if we do end operation here, so we get this one. And this one is easy. Okay. And this one, 101. Yeah, this one. So if we go for the numbers, that would be 192.168 dot, yeah, this is 120. And the last one would be, yeah, this one. So this one is 128, I believe. Let me check. Yeah, 128. Two 240. Yeah, my bad. Just a second, guys. Um, Three zeros. This would be three zeros. And that would become, yeah. And yeah, this is our IP address. So this is the start IP address. And we need to find the end. So we need to calculate using this one, 2 to the power of 7. So 2 power 7, that would be, yeah. So 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32, 32 twos are 64, 64 twos are 128. So the so our starting IP address is this, and the ending IP address is 192 168.120. So the ending one would be 255. Okay, I think there would be one digit off, but we will check that, and we will have 128 IP addresses, and 128 plus 128, it's 250, so that would be 121.0 in thinking. And there would be network address, the first one. Okay, the last one would be broadcast address. Okay, so let's verify if this is the one. Okay, so we'll go take a, yeah, we can do use the any online tool, so MX tool. So yeah, so let's convert this 192 168 120.45 slash 25. So yeah, as I mentioned, we have 128 IP addresses, and yeah, the usable range would be from zero. Yeah, my bad. Yeah, sorry. Yeah, I did some calculation wrong here, but it should be zero. Let me verify that as well. Calculate for 192, 68, 125 slash 25. Yeah, sorry, my bad. I gave 45 here as a wrong one. Yeah. Uh, Let me take it. Yeah, so I think 45, that is fine. Yeah, so maybe somewhere here I'm getting the mistake, but so this would be it mostly. And do you need to practice it? No, it's just the concept. It's better if you could be aware of. Okay, so like this is how the conversion happens, and you usually use this subnet calculator tool to do the thing. And let's going back to our network. Okay, so let's assume we have four devices. Okay, and we do have one router here. Okay, so what do you mean by router? Okay, so there is a switch also. So this we don't use it in our home network, but in a corporate network we do use switch time to time. So what happens is, let's say it switch is like an extension box simply. So you have one your power socket only have eight devices, right? But assuming you do want somewhere around eight sockets, so you do want somewhere around like more number of sockets to be done for the same router. So what you can do is you'll bring a switch, so from that switch, you can the netgate switch is there for an example. So from the switch, you will attach all your devices, and switch is like an extension box. It doesn't do anything. It just forwards the packet as router says. Okay, and the switch looks like this. Yeah, it just have a ports, and this is a big switch where you have multiple ports, multiple PoE ports. Yeah, this is a netgate switch. You need a power socket for this. So depending on the size of the network, people do use switches. So it's not mandatory to use router every time. So you'll use switch to do the extension of your connections and all. So what is the difference between router and switch? Router, as the name says, it forwards the packets as it needed. How about the switch? It's just blindly forwards the packet. So as we decided, if you see a packet, right, a network packet for an example, okay, so let's take an SMS. What do we have? From address, okay, so the source, SMS or an email. Two, that would be your destination, and content. Body is your content and is the data. So the network packet, if you see, actually it will have so many bits. There is a parity bit, there is a correction, there's multiple bits over there. But for our knowledge, we are only depending on this. So like a packet will have this, a source, a destination, and the content. So the router, when it gets a packet, right, it will decide, okay, where to send. Let's say you have one router in your building, okay, and in your ground floor you added one more router, okay, so this one. And you can add one more router here. Okay, so let's say assume a packet is coming from somewhere outside. Okay, so this is your big network. Let's say this is your corporate network. Okay, let's say you have multiple this is a network A. Let's say you have another office and you have another network, a packet is coming here. Okay. So the main router, whatever the router it connects to, it decides, reads the packet contents. Whereas the switch doesn't read packet contents, it just forward directs, where it just blindly forwards the traffic, okay, to everything. Whereas the router will read this network packet, it will decide, boss, so what it is. So you have the source, you have the destination, you have the content data. Let's assume the source is someone like 172 dot something like this. Okay. And the destination is 192, 168, and 120.45. Let's assume this is the destination. And that destination device is here. Okay. And this router has this CADR. Okay. 192, 168, 120.45 slash 25 range. Okay. Let's say this one has somewhere around 192, 168, 172.x. Okay. And this one has a different one. Let's assume 1.0. As I told earlier, so you will divide your network. A big network, you will take somewhere around a big IP address. So you will something like this 192, 168, 1.0 slash 16. So the number it's becoming less, right? So your network range will become more. Okay. So that would be somewhere like this one. 1/16. Yeah. So as the divide says, it says 65,000 IP addresses, and the 19 says 8,005 IP addresses. So let's go for 19 here. So yeah, you divided your big corporate network into this. So you have multiple routers, multiple networks hosting this. So now once a packet is coming like this, right? So a packet has a source as this one, and the destination is this. Okay. Let's say, yeah, let's build a packet. So this packet will go to the router. Router will have the knowledge. Okay, what and all other routers connected to this. Okay, router A. So it will decide. Okay, where is my network and where I'm supposed to send this particular packet and all. Okay, so that's how the router works, and that is called routing in general. And other than that, we have another concept to learn: the addressing, the addresses. So you have something called static IP and you have a dynamic IP. Okay. So dynamic static IP is somewhere you have a permanent IP, okay, which it's not changing and all. Okay. Dynamic IP will have something called lease. Okay. So what happens? The lease could be somewhere around days to hours. Okay, so it could be 48 hours or 1 days or 2 days, something like that. So the dynamic IP after 48 hours, it will release the IP and it will get assigned a new one. So who handles this? That is called DHCP. And if you are wondering why I'm learning about this, because this concept will stay as it is. Whatever you are seeing in AWS, ephemeral IP, static IP, and all the terms are same thing related to this. So you have something called DHCP. What we'll do for DHCP, we'll give a range. Boss, my IP range is this. Somewhere this one, right? We have decided the range here. Yeah, for DHCP, we'll give the range. Boss, this is my network range, somewhere around 128.x somewhere. So this range we will provide to DHCP. So what DHCP will do, for every IP here, so it will try to, let's take this one. For every IP here, it will assign a temporary IP for every device, and then it will release it after the certain lease time over. Okay. And how about static IP? Static IP stays as it is because we will register in the router that my particular one, it should be static IP like this. Okay. And it will get tagged to MAC. I'm not completely sure. Okay. How do we assign, like, okay, this is a somewhere like this is the device X, this is a device Y, W. Okay. So how do we know each this is the one which supposed to get this particular address? How do we identify? So that is called MAC. This is called hardware address. And this is called media access control. But simply you can remember as a hardware address. So your hardware, which is NIC, right? Somewhere I don't have the values here, but yeah. So if you see here, my pi, it has something like this. Yeah, if you see in camera, my device has something like this. I think, yeah, this LAN cable port. This is nothing but a Ethernet port where it has a NIC attached to it, network interface. Okay, so each interface will have a MAC address. So the router will attach the IP address to this MAC. Okay, and I can show you how that is done as an example. I'll show it in my router, my home router. Okay, I need to show it in Geo. One second, guys. I'm running IP config. Uh, yeah, this is the one. My IP address is this. My subnet is this. There is a default gateway. The default gateway here is nothing but your router. Okay, so I'll open this one. Okay, and this is my MAC address. Okay, no, this is IPv6. So I'll show you where is the MAC. Uh, So it may assign to get the IP address automatically. Okay. And there is a DNS also. So what do I do is get MAC address in CMD Windows. Okay. So this should get or get MAC. So I'll run this one. Yeah. This is the MAC address, the hardware address associated with each NIC here. So for Wi-Fi adapter, so I'll log into this router. Yeah, this is my Geo router, but let me log in here. Do have a VM instance because I mean, Yeah, so this is my router. Let me increase the font. Okay. So what do I do? Firewall policy, it's always hello. We'll go to the firewall and we have a WAN and LAN. So what do you mean by WAN and LAN is like your Wi-Fi related the network, right? So here it's specified as WAN and LAN is the one which I showed earlier. So I'll go to that network. Yeah. And I go here. So if I see here, my particular address is this one, 192.168.29.18. Okay. So what do I do? Go to network, go to LAN. Yeah, go to LAN. And yeah, as I mentioned, this is the DHCP setup here. So for DHCP, we mentioned this one, 192.168, 2.255, 2.254. So that is my Wi-Fi range. And this is my lease time. The lease time is 24 hours. Okay. So here is my reserved IPs. So what is my, yeah. So for my one of my device, I added this one and I'm not going to IPv6. So what can I do? I can add a reserved IP for this one also. Okay. Add new. Yeah. So my computer name. I need to see what it's displaying here. Yeah, I need to see how my computer name is displaying in the outside. So that would be here. So, yeah, so this is my computer. My device name is Siddhartha23. So I'll copy this and my IP address. So what I'm looking for, the IP. So the IP would be somewhere this one, 192.168.29.18. Okay, and I also need to provide my MAC. Deconfig/all. So yeah, here there should be physical address. So this is the one. So it says with quotation, single quotes. Yeah. So my computer, now it's a static IP. So even if I reboot my laptop 24 times or after 24 hours also, the IP would be same. Okay. So this is about the static and dynamic IP. Other than this, we have one concept which we discuss, how the internet works and NAT. So NAT is the important protocol which we discuss every day. Like which will be there as part of your life, okay, but which we don't know how it is working. Okay, so let's say this whole thing is protected by NAT. Okay, so that here something called NAT is there. So NAT is called network address translation. Okay, so how NAT works is too simple. So let's say I have my IP address. So I see my IP address is 29.1, and we have something called public and private addresses. Okay, so for this whole network A, okay, so this itself is a public to public. So for router A, B, and C, this whole IP addresses are something called public. But coming to the internet, right? So we do have internet. Let's say here, let's call it internet. Okay. So the for the internet, the whole thing is itself is something called yeah. For internet, this whole block is private. Okay. It only knows our router. Okay. So let's say this main router is there. The router also it's not completely aware. Okay. So how does it works is like this. Okay. So let's call internet. So which internet reports to is something called ISPs. So you have intermediate ISPs. Okay. So this is one ISP, and this is second ISP, and this is third ISP. So you can call this one as Airtel. Okay. So this one is Starlink, and this one is your Geo or Veritas. So now what happens is all the internet providers they have access the direct internet access. Okay, and this ISPs will assign a temporary IP to our router. Okay, so this is my router. So yeah, let's consider this is my router. So what happens? This ISPs will assign a temporary IP. This is called ephemeral IP. Here it's public IP. They also call it as public IP. What it is visible. Okay. And then if I scroll a little horizontal, right? So here is my network. This whole thing is my network. Okay. So from the router, we go here and it will touch our devices, whatever are there. Okay. So now the concept is only the router here we get only one public IP. So all these things, whatever our router has one interface, one public IP, also one private IP. So the 192.168, that is all the private range. Okay. So this whole thing is a private range. So let's say I am someone here outside. Okay. I am trying to access a, let's say I'm someone from internet. Okay. I'm trying to access internet and I'm trying to access the device over here. Okay. So he cannot access it because he knows only one thing that is called my public IP. Let's assume he cannot directly access it. In order to access it, he need to use some other tools. So that one that is tunneling and other things are there, or he needs to send the traffic from here, but he cannot directly send the traffic from here to here. Okay. This whole thing is a one-way protocol. How does it work is it's through NAT. So NAT itself say NAT is nothing but one-way traffic. Okay. So if you ask me, like I'm able to browse the internet, right? So that is your one-way traffic. So it goes the similar way. Yeah. So I'm able to browse the internet, but why you're saying someone from the internet cannot reach my device, okay? Cannot actually access my device. That is because your router itself does this NAT procedure without we being aware. So what it does is, as we mentioned, the packets, right? So source, let's say the flow goes like this, okay? So you have the source is my mobile, okay, iPhone. Destination, I'm trying to reach google.com, and content, it's a get, okay, get the page. So this is the packet, okay. I'm sending the packet from here to router will get and get the answer, okay. What router does is it will change the this it will change the source. This source is nothing but my public IP, the ephemeral IP, what is that's provided, okay. And it would be, once it gets the answer, right? So the source would be google.com and the destination would be public IP. Okay. So here router adds a identification tag here. Okay. So that's what I'm assuming. I never really inspected it. So the router adds a identification packet that, okay, this is came from this particular device. Okay. So once the traffic gets to the router will re-examine the content. It says like, okay, it does belong to some guy named some the iPhone device. Okay. I'm supposed to forward the traffic. So what it does is it will rechange the, yeah, it will rechange the one. So from the source should be google.com, but the destination would be iPhone. So this whole thing is called NAT. The router does this NAT procedure. Okay. And here if I see somewhere I would see this. Yeah, it's okay. So why we are discussing NAT? Because NAT is everywhere. If you spin up a VM in AWS, okay, if you spin up the any VM everywhere in public cloud, by default you'll get a NAT and you'll get the public IP. Okay. So even if you see the VM, right, somewhere here, if you see earlier, I'm not sure if where people are joined. So we discussed one topic here that is in the network here. So mission settings. Yeah. So if you see here, you have something called NAT and bridged. Okay. So what exactly is the NAT and bridge is? Uh, so even if you spin up a VM, okay. So this is the VM. Let's assume this is your laptop. Okay. And let's assume you spin up a VM here. Okay. So a VM is nothing but a virtual machine. It also has a network, right? So what it says is, see, this IP address is 18. Okay. So what this VM says is, should I get my own network? Okay. Or that is the NAT. No, should I get my own network? Or should I get a NAT with the own network with the NAT? Or should I attach to the laptop network? So if it attaches to the laptop, it will also get the same IP. Yeah, it will also get an IP. But usually we don't allow this one, the VM to attach to the laptop network, the network interface. So we do use it NAT and we do something called port forwarding. I think we are getting end of the session. So we do something called port forwarding. So I'll explain you a bit what is the port forward. I think that would be the last thing. And before this, as I mentioned, we'll get a public IP as I mentioned, right? Okay. So we can check in the internet. What is my public IP? Yeah. So things are updated. Now we are getting the IPv6 also. So if you see, this is my public IP 49.37.148.229. And it is assigned by Reliance Jio, and it's giving my location, not accurate, but it's giving my state location and all. Okay. So this is my public IP. And we are coming to the port forwarding topic, right? So what we happened is like VM has a NAT and we are trying to forward a port, right? Through, if I want to connect a VM from here, okay, so I cannot directly jump to this network. Okay, this would be somewhere 172 or something. Okay. So what I'm supposed to do, I'm supposed to do a port forwarding from here to here. That is option one. Or I need to attach to the laptop network, which I don't want to do. So let me do a port forwarding. I'll go to NAT. Okay. So this is the port forwarding. So what I do, the host IP, the guest IP, I will not change anything. Uh, I'll just give like the guest port would be 22, the host port would be 127. So 127.0.0.1. Okay, let me check if it is working. Okay, yeah. And let me check my IP address here. What did we got? Okay, so skip, open a terminal. So IP config is Windows. So I think here is if config. Okay, so if you see here, I think it got the host one 92.168.29.15. Thought I changed it. Okay, let me disconnect the internet. Let me reboot it. Reboot. Since the time is getting up, right? So I try to take this in the next session. Better the port forwarding, the TCP/IP ports. Um, I think those are the things. And if any, there is any other thing, the firewall related things and the DNS. So I'm not sure when to host the next session. Maybe Monday or should I host it in next Saturday? So we will see. Before concluding, do we have any doubts? Yeah, plan it in weekends, bro. No doubts from my side. Yeah, thank you, Vihari. Yeah, any others have any doubts or we'll see them. Okay, so I'll try to conclude it here. Maybe I'll plan the next session on the Saturday. Okay, thank you, guys. Thank you.